Hello, students. We're doing a section on transformations. There are 3 transformations that maintain congruence. The rigid motions. The first was reflections, and we talked about translations. Now we're going to talk about rotations. So what is a rotation? Well, the word rotation we see in a lot of different contexts. I like to think of tire rotations. There's the earth rotation around the axis, crop rotations, exercise. All of these things are rotating, and rotation is a really powerful concept for creating 3-dimensional shapes. In calculus, we use rotation a lot. In geometry class, this is the definition of rotation. So a rotation, notice we've already used r for reflection, so we're going to use a lowercase r. And then we have, it looks like a point, but it's not a point. It tells you the degree of rotation, how much to rotate it, how much to turn it, and it tells you the point about which you're going to turn the object. So the notation has a little r for rotation, it looks like a point, it has the degree of rotation and the point around which you are going to rotate the object. P is the center of rotation. The angle has to be given. And if you are rotating around the center of rotation, that point is not going to move. Let's say we're taking this triangle ABC and I want to move it over there. I'd kind of like swinging it that many degrees that way. So you can see this says it's a rigid motion, so the length and angle measure are preserved. So this triangle is exactly the same size and shape as this triangle after the rotation. Also, it says, notice that this angle is measured in the counterclockwise direction. All right, so let's try one. Here's looks like a trapezoid. These lines look parallel to me. And we want to rotate it 90 degrees. So the R stands for rotation, and then 90 degrees. And we want it, comma, about point O. And in this problem, point O is right here. That's the origin. You have to define your point of rotation. For this class, we're only going to use the origin as the point of rotation. What I sometimes do is I put my hand, I put my thumb on the point of rotation, and maybe like I'll point to A, and then I'll spin my hand. So I'll put my thumb at the point of rotation and point to one of the points, and then I'll spin my hand 90 degrees. I'll turn it like that. So I want to actually do point D first. So I'm going to draw this out here. And D is this point 2, -1. And if I spin D counterclockwise 90 degrees, where is it going to land? Okay. One way to think about that is to make a couple rays. You want to make a ray that includes D, and you want to make a ray that's 90 degrees away from that. It's a little bit hard to see, but you guys, I'm trying to show you that that right there is a right angle. So from D, spinning in here to a right angle, the new D is going to land right there in the interior of this trapezoid. Okay? These are a little tricky. So if I was going to put my thumb on the origin and then point to D and then turn it 90 degrees, that's where D would land. Okay, I can do the same thing with, let's do point A. There's a couple ways to do this. I know that D is 1 away and 1, 2, 3, 4, 5, 6. So as soon as I know that, I could just use that for the next point. But I'm going to keep going with this. I'm actually going to erase this right angle here. Oops. We already figured out where D was. I'm going to do the same thing again. And now I'm going to create an array up to A, containing A. Out there. Okay, so that's basically up 1, 2, 3, 4, 5 over 3. So if this is a line, remember we talked about perpendicular lines. If this line has a slope of 5 over 3, what's the slope of the perpendicular? It's going to be negative, and it's going to be 1, 2, 3, 4, 5, 1, 2, 3. It's going to be out here. Oops. Can you kind of see what I'm doing there? I made a perpendicular line. That's 90 degrees. So if A is out here, A is going to spin and it's going to land over here. Instead of 3, 1, 2, 3, 4, 5, it's going to be 5, 3 right here. All right, these are a bit tedious, a little hard. You can also see that it's 1 away. Wait, yeah, it's 1 away from D prime and it's 1, 2, 3, 4, 5, 6. 1 away and 6 away. All right, let's get rid of those and do it again. I wonder if there's an easier way for this kind of rotation. Should we do B? And B is 1, 2, 3, 4, 5, 6, 7 over 1. So the array that contains the origin, point O, and B is really steep. Okay, it's basically a slope of 7. 7 over 1. So what's the perpendicular? What's the 90 degrees of that going to be? Well, it's going to be, instead of up 7 over 1, it's going to be 7 over 1. Yeah. Does that look like 90 degrees to you? It does to me. So the new B is going to be 2 away and 2 up from A, 2 away and 2 up from A. So it's going to be over here. There's the new B prime. There's A prime and B prime. This segment is the same size and shape as this segment. Okay, and the last one. I think this one I have enough information that I'm just going to figure out how far it is away from B. So it's 1, 2, 3, 1, 2, 3. Okay, so if I go 1, 2, 3, 1, 2, 3, that's gonna be my new C. Ooh, all right, let's take a look. Did I do it right? Wow, this shape, the image, is exactly the same size and shape as the original, but it's turned. Okay, so BA was kind of at the top, and now it's kind of at the side. Oof. I wonder if there's an easier way. It can be helpful to memorize the relationship between the coordinates of the original and the image. So if I'm going to take point A and I'm going to swing it 90 degrees, remember we always go counterclockwise, we can kind of look at the relationship. So the degree of this rotation in the figure is 90 degrees counterclockwise. If I wanted to write this with the notation, it would be rotation of 90 degrees around the origin, and what are we doing that to? We're doing that to point A. Okay, then we can look at the original was 1, 2. It's okay. And then the new one is 2, -1. So what happened? The x and y got, So it's kind of funny. The x went there and the y became the opposite. See how 1 kind of became the y value? It's interesting to look at that. Yeah. Okay, so could I do this problem with just looking at the coordinates? The original coordinate for A is, 3, 1, 2, 3, 1, 2, 3, 4, 5, 3, 5. And we just learned that if you're doing a 90-degree rotation, you're going to take the x and y coordinates, and then you're going to switch the x and the y, and make the y the opposite. Okay, so the new A prime is going to be, let's see, x is 3, so that's going to go over here. And y is 5, and now it's going to be -5. Let's see if that makes sense. So it was here, and now it's -5, 3. That's where we had it before. And it was a little bit easier just to do the coordinates. All right, let's finish up. So B is 1, 7, and B prime is going to be -7, 1. C is -2, 1, 2, 3, 4. And C prime is going to be -4, -2. Right here. That's the new C. I forgot the new B. -7, 1. And the new D, it was originally at 2, -1. And the new D is 1, 2. 1, 2. Again, if you look at it, it's 90 degrees from where it started. If you make a 90-degree angle right here, you can see it. Okay, that's how you do that. Let's look at another one. This one is one of my favorites. So what if I want to swing point A halfway around the circle? What if I want to swing it exactly 180 degrees? So what happens to the coordinates? This is a rotation of 180 degrees about the point O, which is the origin. And we're doing that to point A. And we want to know what happens. So the original was 1, 2. And the image after 180-degree rotation was -1, -2. This one's actually a little easier. So what happened to the x and what happened to the y? To get from 1 to -1, what do we do? Take the opposite. And to get from 2 to -2, what do we do? Take the opposite. That's pretty cool. All right, so let's see if we can put it into use. So the vertices of triangle XYZ are -4, 7, 0, 8, and 2, -1. What are the vertices after a 180-degree rotation of that triangle? I'm not going to draw the triangle at this time. I'll show you what it looks like in a minute. I just want to try to use the formula or the rule. Okay, so 180-degree rotation, the x's are going to become the opposite and the y's are going to become the opposite. So if x was -4, 7, the new x, the point x, is going to be the opposite of -4, which is 4, the opposite of 7, which is -7. Y is 0, 8. The opposite of 0 is 0. The opposite of 8 is -8. And z was 2, -1. And the opposite of 2 is -2. The opposite of -1 is +1. So that's how you could do that one pretty quick, as long as you have this concept memorized. Ooh, this one's fun. So another thing we can do is rotate it 270 degrees. So we got a 90, we got a 180, we got a 270. What happens if we rotate it 360? Okay, so this one, the notation would be lowercase r, 270 degrees. We're going counterclockwise around the origin. And we're doing that to point A. Point A was originally 1, 2. And after the rotation, the image landed at 2, -1. So this is like the first one, like the 90 degrees, but it's switched. So where did the X go? The 1 became -1. And where did this Y go? It came out to the front. So if you memorize these 3 basic numbers, it can save you a little bit of time. Okay. I can also use technology to do it. So should we practice this first? Okay, let's practice it. So we have X was -4, 7, and the 270 degree rotation, I just wrote it on the last one, but you're gonna switch the Y, put the Y in front, and make the X the opposite. You can look at it. Yeah. Just double check. Okay, so X prime is going to be 7, +4. Y 0, 8. Y prime is going to land at 8, 0. Opposite of 0 is just 0. And Z is going to be 2, -1. It's gonna, Z prime will be, the image of Z will be -1, -2. I want you guys to start, here's a shortcut way to look at the notation that we just talked about. I want you guys to start getting used to some tools. This is one that the calculus teacher uses a lot. It's called GeoGebra. And I want to show you just for a second how to program the computer to do the rotation for you. Especially because these are a little bit challenging to do by hand. So this is the GeoGebra program. I already built the polygon and I turned on the axis and the major grid lines. So you can turn that on and off. Before you build your polygon, you're going to want to turn on the axis and the grid lines. All right, now if I want to rotate this and I don't want to do any work about the origin, the next thing that I have to do is put a point at the origin. Okay, it calls it point D, it could be point O, I could probably change it's fun to learn computer programs and play with things. I could change the settings and I could change the letter to O. Okay, because that's fun. Oops. Undo is a really good button for this. See, now it's called point O. I'm using the tools at the bottom. These, if you can't see them, you need to press the word more, and then you scroll down all the way. We're doing transformations right now. And the one I want to do is I want to rotate around a point. It says select the object to rotate and the center point, and then enter the angle. So if I click on it, it kind of tells me how to do it. So I'm going to select the object. Okay, got highlighted, that's good. And then it said select the center point. Bloop. And now it pulls up this menu. See how it's set to counterclockwise? Because that's the way we rotate things in math class. And I want to do a 90-degree angle. And boom, look, it did it for me. Or I can do a, oops, and do 270 degree angle. That's kind of cool. So make the computer do the hard work for you. You can screenshot this and attach it to the homework. It's a good thing to do. Play around with it, have fun with it. One other thing that's slightly interesting is that you can actually not do rotations. You can do two reflections. Two reflections is the same as a rotation. So, you could straight up rotate it to get from here to here. Or you could reflect it over one line and then reflect it over another line. Those lines have to intersect at where the point of rotation would be. So what's happening here is this A is being reflected over line M, and then A prime is being reflected over line N, and it's going to land at the same spot. It's kind of interesting. Okay, that's the lesson for today. There's a fun Desmos activity. Be good, do your homework. Bye. All right, well, not my best lesson. Okay. Yeah, whatever, it's fine.